We've all dreamt about it, right? From H.G. Wells all the way to the latest blockbuster, this idea of traveling through time, it's just so captivating. But here's the big question. Is it just a great story, or is there some real honest-to-goodness science behind it? Well, let's dive in and find out. Yeah, that's the ultimate question, isn't it? And look, while it might sound like something straight out of a comic book, some of the absolute greatest minds in history, I'm talking about Albert Einstein here, they took this stuff very seriously. His work completely flipped our understanding of time on its head. He showed us that time isn't this constant ticking clock. Nope. It's actually a dynamic, flexible part of our universe. So, to get our heads around this, our journey really has to start with a puzzle. A puzzle that totally baffled physicists about a century ago. And it all boils down to the incredibly bizarre behavior of light. See, light it plays by a completely different set of rules than anything else in the entire cosmos. Okay, think about it like this. In our everyday world, speeds just add up. Super simple, right? But light just shatters that rule. Its speed is absolute. It doesn't matter how fast you're going. And this one little fact forced Einstein to a pretty radical conclusion. If the speed of light is the one thing that can't change, then something else has to. And that something else? You guessed it. It was time itself. See, Einstein figured out that space and time are actually woven together into this single fabric he called space-time. And this fabric, it can be warped, it can be stretched, and get this, the faster you move through space, the slower you move through time, at least compared to someone who's standing still. And I'm not speaking in metaphors here. This is a fundamental law of our universe. This is where it gets really wild. Imagine you take a trip, and for you, it feels like 7 years. But when you get back home, you find that decades have passed on Earth, 42 years to be exact. Your personal clock just ran way, way slower. You didn't just get a peek at the future. You literally arrived there. So, there you have it. Einstein basically gave us a roadmap with two potential paths to the future. One is extreme speed, like we just talked about. The other? Extreme gravity, the kind you'd find near a massive black hole. It warps space-time so much that time itself just slows to a crawl. So, according to all the math, traveling forward in time isn't just some sci-fi dream. It's pretty much a given. Okay, so that naturally leads to the big one, right? If the door to the future is theoretically open, what's stopping us from going back? Why does the door to the past seem to be locked and bolted shut? Well, this is where things go from being complicated to being profoundly weird. And to really wrap our heads around the puzzles of traveling to the past, we have to take a quick detour. We need to understand that the universe, it's just so much stranger than it looks. We're going to peek into the quantum realm, and trust me, this is where reality gets wonderfully weird. So, first things first, forget everything you think you know about what empty means. Because on the tiniest scales, the emptiness of space is, it's anything but empty. What it actually is this roiling, chaotic sea of what scientists call virtual particles. They're popping in and out of existence for just fractions of a second before, poof, they're gone again. This quantum foam, that's the true baseline of reality. And it has real, actual, measurable effects. One of the coolest examples of this is something called the Casimir effect. Here's the deal. You take two metal plates, put them super, super close together in a vacuum. It turns out all those quantum fluctuations happening outside the plates are stronger than the ones happening between them. And that creates a real pressure that literally pushes the plates together. It's a physical force born from absolutely nothing. And you might be thinking, okay, but how strong can that be? Well, get this. At a separation of just 10 nanometers, that's incredibly tiny. The pressure is equal to 1 full atmosphere. That is the exact same pressure you feel from the air around you right this second. So, if reality at its most fundamental level is this strange, what does that tell us about the problem of going back in time? It turns out the biggest hurdle for traveling to the past isn't about building the right machine. It's logical. It's all about this little thing called causality. The simple rule that a cause has to happen before its effect. And the most famous, classic challenge to causality? That would be the grandfather paradox. It's this perfect, impossible loop. Think it through. Each step makes perfect sense, right up until the very end, which completely blows up the beginning. If you succeed, you fail. Because if you were never born, well, how on earth could you have traveled back in time to start this whole mess? It's a perfect contradiction. and it really seems to slam the door on changing the past. So, yeah, it really seems like a logical checkmate, game over. But remember how weird the quantum world is? Well, physicists, armed with all that strangeness, have actually come up with a few potential ways out of this mess. Okay, so there are two main ideas on the table. The first one is called the self-consistency principle. Basically, it says the past is set in stone. No matter what you try to do, the universe itself will conspire to make sure everything happens exactly as it's supposed to. Maybe your weapon jams, you trip over a rock, whatever it is, your trip to the past was always part of the story. Then there's the second idea, the many worlds interpretation, and this one is even wilder. It says that when you change something, you actually create a fork in the road. You split reality and create a brand new parallel timeline, while your original one just keeps on going, completely untouched. So think about what that means. If the many worlds idea is right, then traveling to the past is strictly a one-way trip. You'd basically be in exile in a new reality that you just created, and you could never get back to where you started. This might even explain why we've never met any time travelers. Maybe they're all out there, just branching off into new timelines, unable to ever get back to ours. And that leads us to one final truly mind-bending thought. What if this many worlds idea doesn't just apply to time travel, but to every single choice and every quantum event? That would mean an infinite number of parallel universes are being created, every single instant. Which kind of begs the question, doesn't it? Of all the countless versions of reality out there, which one are you in right now?